find the perfect envelope, the perfect mechanical system. It can be installed perfectly, but you never know how people are going to live. Do we have aquariums? Do we have pets? How many plants do we have? There's so many things that everything works until you put people in it.
This is the one and only, the original podcast where you can find yours and your business's true value. You're listening to Our Value.
Brought to you by America's insulation source, IDI Distributors.
You want to hear from the best contractors, suppliers, and consultants that dedicate themselves to more than just survival in the business world?
Industry professionals that are dedicated to excellence in every aspect of their business.
Our Value has them all here to share that same motivation and knowledge with you. Tune in and grow a more successful, profitable, educated, and recognized business. Listen to the Our Value podcast to become the industry leader in your market. Find your value with Our Value.
Welcome to today's Our Value podcast. Today, I have something for you. I am talking with Nikki Kruger. For those of you that don't know her, she speaks at the International Builder Show. She speaks all over the place, but right now she's speaking here. And so today we are going to talk about buildings, getting tight with buildings, and what we need to do to take care of them. Nikki, how are you doing today?
I am doing very well. We are in the cusp of our busiest season, of course, humidity season, but doing very well.
Nikki, I know you just left the Building Science Convention and some stuff came up there. I was going to tell you, even yesterday, every class that we give at IDI, I get asked, shouldn't buildings breathe? And laughingly, I answer no, because houses don't die. They're already dead. People, on the other hand, do die, so they need fresh air. But what are you seeing as the best solution for providing fresh air to occupants now that our air sealing efforts are eliminating a lot of the leakage?
Yeah, we get this a lot with builders. We didn't have these problems in our homes until they made us, start building so tight. And I think that what we're seeing is that the progression in the advancement in our building envelopes has been embraced very rapidly by building code, by builders. We're doing blower door tests. We're really making sure our envelope's tight, but maybe our mechanical systems haven't kept up with how quickly our advancements and constructions of the envelope have. So while, we've always kind of had these, this is how I've always sized the HVAC system without the HVAC contractor necessarily understanding that the envelope really is affecting the sizing and the runtime of our systems. And then also, now we have that need by code to bring in outdoor air because our houses are getting tighter. So I think it's, a lot of fingers start pointing when we see issues with our construction of maybe not being comfortable, feeling like our home isn't healthy. But the reality is we're just need everybody working together to make sure that we're sizing the HVAC equipment correctly, bringing in the mechanical ventilation, which is, what you were talking about. And there's a lot of strategies based on climate zone, what that strategy could be and for that mechanical ventilation. And then making sure that, when our AC isn't running, that we've got some sort of dehumidification strategy. But, you can use supply ventilation for that fresh air. You can use exhaust, which in certain climate zones, we don't recommend. And then we've got the balanced ventilation, which is, the ERVs and HRVs. There's all different kinds of strategies. And, people always ask me, well, what's the best one? And I'm finding more and more, it depends. It depends. If we're getting into passive house levels of air tightness, you're probably going to need balanced ventilation and ERV. If you're in a hot, humid climate, or just a mixed humid climate, supply ventilation obviously is where we want to go. A slight positive pressure, because we have so much negative with our bath fans, our kitchen hoods, and our dryers, open up doors. Exhaust, I would say typically is a heating dominated climate strategy, but more and more I'm seeing supply ventilation being used predominantly in those climate zones as well. So, the one that scares me the most is exhaust, because it is the cheapest upfront. But typically when I get called into homes that are having issues, it's because they're using exhaust only ventilation in a humid climate.
Yeah, I think exhaust, you said it, it's dangerous. I knew someone who was involved in a Habitat for Humanity home, and they moved in March of 2020. A Habitat house is perfectly sealed because you have 70 volunteers and you give them all caulking. You can't give them saws and hope to wind up with a house. So you give them all caulking and you get this super tight envelope. Well, the only fresh air, in fact, the microwave over the stove was not vented out, it was recirculating.
Yeah.
And they used the bath fan method where we just run a bath fan 24/7. This house, 6 months in, had green mold growing on the furniture, and all of the, everything from cooking was pulled from the kitchen into the living room and down the hall toward the bath, but never really made it out. As that air cools, the moisture is just going to collect in, cold corners and places like that. So it's a real problem. I know a couple of years back, you and I talked about a large complex that you said the whole place failed because they were going exhaust only.
Yeah, I got called in. It was in Maryland, to a community of townhouses, and it was especially the interior units. So, it seemed like the larger townhouses were on each corner, but then all the interior units were experiencing issues. And that's, first of all, because the heat gain is a lot less, right, on these interior units. So they're not running the AC as much. And then on the very top floor, I think they were 3 or 4 levels, the top floor and there are 4 levels. The second floor and the 4th floor were running continuous bath fan. And it was, I walked in and I'm like, you've got to shut those off. And they're like, oh, no, we can't. Energy Star says we have to ventilate. And I'm like, well, yes, Energy Star says you have to ventilate, but you chose the cheapest option. And they were in litigation. And of course, I always find this, no matter if it's a multifamily or if it's single family communities, as soon as a couple people start becoming verbal about the issues they're having, the whole community is now searching for those exact same, and they find them, right? I mean, So yes, you've got to ventilate, but you got to know your climate zone. And the reason that we don't want exhaust only is because when we're sucking out, we're bringing in through every crack and crevice, uncontrolled, not filtered, not knowing where it's coming from, not knowing where it's going to condense. So not having that control is where we run into problems. So that exhaust only is kind of like the wild, wild west. And depending on, how cold those surfaces are, one of those bathrooms they were sucking in had also a supply register. And so what was happening is that bathroom specifically had a lot of microbial growth because it was so cold in that bathroom, and they were sucking in, and they were exhausting, and they were pulling in. It was like backdrafting through there.
Well, and you mentioned even from the garage into the units, there was so much water being sucked into the insulation of the ductwork that this wound up being quite the litigation. They were closing units and moving people out and having to repair buildings. These aren't little problems that this creates.
No, and what the builder wanted to do for one of these projects was the homeowner, or the townhouse owner had to drop their ceiling in their master bedroom because the condensing water was so bad on the ductwork. So they actually tore out their ceiling. And then you could see in the rimming band where the fiberglass insulation was, all you had to do was pull that out and you could see how dirty it was. And, we were actually standing in there and we could smell what the neighbors were partaking in next door in their townhouse. Well, the builder came in and said, well, since you already have that ceiling dropped, we're just going to go ahead, we'll spray foam that ductwork, because obviously, when they insulate that ductwork, a lot of times where they miss getting it really secure is at that top part, right? You go around and it's a rigid duct and they're trying to seal it and you can't get a perfect seal on it. So when there's infiltration at that ribbon band, it's also hitting that ductwork. And they're like, well, since you already dropped this, we'll spray foam. But that ductwork went into a hallway and 2 other bedrooms, but they weren't going to drop the ceiling there. So we were trying to explain to the builder that you can't just do a section of that ductwork. Air is going to continue to find where it's not insulated perfect, but to them, that was a solution.
Well, maybe if you just move the problem a few feet, then when you hit the end of your 10-year warranty period that you're on the hook for the building, you won't have run out of space.
Yeah. What's always interesting to me is we get called in, I get called in, and then they're like, okay, well, we're just going to throw a dehumidifier at this. And if you ever listen to Ken Gehring, the gentleman who, was heading up inventing our whole house ventilating dehumidifiers, and we were the first to market with the standalone crawl space dehumidifiers. He's 84 years old and he's on a forum called HVAC Talk, and he'll be the first to tell you when a dehumidifier is not going to be the solution. There are steps that you need to take in order to ensure that it's going to be successful. And just throwing a bigger dehumidifier at it is not the solution. Can we air seal everything tight in retrofit situations? Absolutely not. We understand that. But we should try to mitigate the infiltration as much as possible and get our ductwork tight. Make sure that we're looking at the solutions that make sense from a cost perspective for our customers. And then we can look at adding a dehumidifier to fix it. And then, builders need to understand that there are going to be times when, if you're not using dehumidifiers up front, that, okay, but prepare to have one at some point. So leave room for it. I mean, that's my biggest challenge is when I go into a lot of these projects, they want me to help fix them. And I'm like, I'm not sure where I can put this dehumidifier. And the solutions that I'm going to give you are probably not what you're going to want to hear because, you didn't leave a mechanical room space, or I can't find space in the attic in order to put it. So more and more we are seeing builders say, okay, we might not put this in at the beginning, but we're going to leave room, which is good insurance policy to plan for.
That's a good idea. Now, you look at these buildings, you talked about how tight they are and you talked about sizing, but realistically, when we look at sizing, how often are you seeing mechanical contractors that are truly downsizing enough to handle the loads that are now created inside?
The sensible load or the latent load?
The latent load.
The latent load.
Wait, hold on. We just threw out 2 terms. Do me a favor and cover those terms before you answer.
Okay, the load. Okay, so the sensible load is what the temperature is and what the thermostat's trying to get that HVAC system to. And the latent load is the moisture in the air, which is being removed, hopefully as a byproduct of trying to get to that temperature on the thermostat. So, more and more we're seeing HVAC systems that have a dehumidification mode on them. You got to be very careful using those because all that is doing is slowing down the fan and running the system longer. And what can happen is we can create some very cold spaces, especially, the most, relatable one is oftentimes when I say, if you got a metal register in a hot, humid climate and you start seeing condensation on those registers, that's probably because we are overcooling to a point of trying to remove more moisture, which instead of being, kind of, hot and sticky, now we're cold and clammy, right? So it's like from one to the other. When we aren't actually setting it to get to a specific relative humidity set point. It's just running it longer and cooling more, trying to remove more moisture. So you got to be careful using that. But when we look at sizing the I'm seeing more and more that we're seeing the manual J's done on our mechanical system, which the HVAC contractor does in order to determine the size of the HVAC equipment. So, putting in what's our ventilation rate, what's our peak, heating and cooling loads. The challenge with these is I'm also seeing the peak loads being fudged with, instead of using the data that they're pulling, weather data that they pull that automatically populates in the manual J. They're saying, well, you know what? On July 4th, when they have 30 people over to their house, I don't really want to get a call because the AC can't keep up. So we're going to play with this number a little bit, and we're going to, fudge that peak cooling number up higher. So that leads to oversizing of the AC system. The challenge with that is normally, even at our peak loads, about 1% of the time our systems run at that peak load heating and cooling. So they designed the system for 75 degrees and 50% relative humidity. That system hopefully is then sized at the peak time of the hottest days of the year that you'll be able to achieve those numbers. So what happens, you can, and getting the cooling, you can achieve a lot more, right? But getting that dehumidification, you're only going to get that with a long run time on the hottest days of the year. So you've got to figure out what your dehumidification strategy is going to be outside the hottest days of the year. When you're at the partial load AC run times, and even more importantly, the no load, because yes, AC is going to help control the humidity when it is running. It's when it's not running that you've got to think about how you're going to do that. And the tighter the homes get, the better our envelopes get, the less HVAC run. That's the goal. That is the whole goal of making our homes so tight, is to run the largest unit in the house as little as possible.
Yes, it is. And that's one of the things I was going to ask you about, because you look at seasonal challenges and solutions for managing humidity, in different climates. Not everybody has a problem with this, but shoulder seasons along the coast, shoulder seasons along the Gulf, shoulder seasons in Texas, shoulder seasons in Kansas. If I super insulate a house, I can make the whole year a shoulder season. So, when I'm talking about times that my AC isn't going to turn on, how do you see those being addressed, and how would you address them? I mean, if the system isn't going to run, how do you run air through the ductwork just because you've got a dehu?
Yeah. So yes, a whole house dehumidifier. Now, again, you can use it for ventilation if you want, which is supply, right? Bringing in outdoor air through a MERV 13 filter. So we're filtering the air from the outside, MERV 13, plus all the return air to the dehumidifier. And then you tie in that dehumidifier, the air coming out of the dehumidifier, onto the supply side of the AC system. So we're just utilizing that supply ductwork to distribute the dry air to the entire house. So we have a relative humidity sensor located in the living space that's going to say, okay, let's say we're going to set it at 50 because that's our manual J. Okay, we're above that 50% relative humidity. We're going to turn the dehumidifier on, the compressor and the fan, and we're going to dehumidify the entire home, regardless of the AC runtime. Now, there's a strategy where you can lock out the dehumidifier and the AC from ever running at the same time, which, AC is, like Ken would say, AC is king, dehumidifiers are queen. When the AC is running, we should be setting that up to remove the most amount of water as possible. Now, the challenge with that is, these AC manufacturers, when they're giving you their SEER number, which is telling you how energy efficient that HVAC system is, it's running at the highest fan speed and typically at a warmer coil setting of like 59 degrees. So that's how they get so energy efficient, is because they're just focusing on that 59 degrees to get that thermostat to that set point. The challenge is you're not really removing as much water as our old systems that used to be at a 49 degree dew point temperature on those coils. I mean, when they ran, they removed a lot of water. They might not have been as energy efficient, but they removed a lot of water. So, getting our systems to remove as much water as possible when they're running is key. And then when the AC shuts off and the humidity sensor says, well, we're not at, the 50% we want, then the dehumidifier can come on. The other strategy is a lot of homeowners like, I don't really care if the AC and the dehumidifier run at the same time. I want that RH set point to 50 as much as possible and just let them both, run when they need to run. So, but we are seeing, I mean, like I said, I think we will be close to 30 years in 2025 that we launched the first whole house ventilating dehumidifier. And of course, most people are still, not aware of the technology or understand how to use it. But I would say in the last 10 years, probably the awareness has really skyrocketed. And now we have our Indoor Plus programs, our Energy Star, our green building programs, all saying, if you're in these climate zones, which typically is what we call a green grass climate. If you can look outside and you see green grass, that probably means that you're getting an inch of rain or a week in order to maintain that green grass. You're going to need some sort of dehumidification strategy, either below the home or in the home or even above the home at some point during the year. So that's what we look at when we say that, your dehumidification strategy might depend on typically where you live, but if you've got green grass, you're probably going to need some sort of dehumidification strategy, which these programs now have worked into their standards, because you can have an extremely energy efficient house, but if it's not comfortable and your indoor air quality is bad, it doesn't matter. Nobody's going to live in it. And you're going to, and those builders and those contractors are going to get callbacks.
Yep.
So yes, like Dr. Joe Seabrook says, I was at one of his trainings and somebody was saying, well, you're telling us, to make all these buildings tight, but then we got to add a dehumidifier. And he's like, 10 steps forward, 1 step back. You cannot, you cannot energy efficiency. Well, what did he say? You cannot design systems to not use energy to dehumidify, basically. I mean, it's going to cost you money, just like ventilation, just like heating, just like cooling. It is going to cost you some money to maintain a healthy, comfortable home. We just want to do it as energy efficiently as possible.
So I have just a side question, because so often we can be okay in terms of design, but then we get to occupant behavior. Now that we're you shake your head. So now that we're doing these tight builds and these envelopes, what are your thoughts on just starting to make sure all bath fans have humidistats? Because I'm a fan. I'd put them on a kitchen hood.
So interesting that you say that, because there was a very large builder in the Mid-Atlantic that put humidistats on all their bath fans. But the challenge was they came on in the spring and they never shut off until winter, because if they were exhausting, and when you have a humid, like a wedding event in a bathroom, okay, it's going to turn on. I'm exhausting, but now I'm also sucking in air from the outside. And pretty soon that humidistat is never going to shut off because it's always humid.
I think that happens though, because what I'm getting at, what I love is you guys is ventilating dehumidifier. If I can make sure that my baths don't, cap me off at the knees, and then the air that I bring in, I dry on the way in, I think I've got a good system. But otherwise, you're right. If we start pulling air out and the air outside is wet, we're just wetting the house again.
Yeah, exactly. No, so I think as long as you've got a supply ventilation strategy in conjunction with using bath fans, I like the timer bath fans personally, because I think that's the biggest problem is people go in, take a shower, turn their fan on, and as soon as they leave, they shut off the fan. And really, you need about 20 to 30 minutes after you leave that bathroom in order for that humidity to to dissipate, whether you leave the door open and some of it goes to the rest of the house or it goes out. But I really like the timer method. Now, with our ventilating dehumidifiers, we can bring in based on a timer schedule, right? So I'm going to ventilate 20 minutes of every hour, or maybe, you can even lock out, like, okay, nobody's home from 8 in the morning till 6 p.m. I'm going to start ventilating at 5 p.m. before people get home, to start purging any, indoor air quality contaminants that have, off gas during the day. And then, ventilate when that's when you need to ventilate, is when we're occupied, right? When the house is occupied is when you need to ventilate. Now, our dehumidifiers are going to, the ventilation with those is basically, okay, I've set up a ventilation timer strategy. That's going to activate the fan on the dehumidifier and a power damper to the outside, and it's going to bring in outdoor air. Now, it does not automatically activate the compressor in that dehumidifier. So that compressor, which is what, gets the coils cold to remove the water, that is going to be activated by the sensor, the humidity sensor in the living space. So it might be, humid outside and the dehumidifier compressor is not running, but the fan turns on, we bring in that outdoor air. And if the AC is running full blast at 3 o'clock in the afternoon, that AC might be able to handle that small amount of ventilation air we're bringing in. When the compressor is going to come on is when the space says, okay, we're above our set point. Now we're going to activate the compressor, and we could be bringing in outdoor air at the same time. And we'll get some water removal from that outdoor air as it goes over the cold coils. But, people always say, oh, well, can I just ventilate, dehumidify all that outdoor air I'm bringing in, which is a commercial strategy, right? In commercial buildings, they do that a lot. The challenge with that is if you're in a climate where you have high dew points starting in April, May, and lasts through September, October, you're going to be running the compressor on that dehumidifier a lot in order to remove a small amount of moisture from a small amount of air. Plus, when a dehumidifier runs, it generates heat. Now, your shoulder seasons, not a big deal. Typically your shoulder season that's a little cooler, a little bit of heat, not a big deal. But if you're, in the middle of summer in a hot climate, you got to be cognizant of how much heat that dehumidifier potentially can generate and how we're distributing it throughout the house and mixing it with the return air from the house.
So if we go to, let's now talk super insulation, super tight. When we look at passive house, really, we'll just say annihilating the bar instead of setting the bar. How are you seeing those types of projects address their mechanical needs and humidity?
Yeah, so we are, more and more, we are involved in a lot of passive houses because, again, they're just not seeing the runtime on the AC systems. Now, typically, those for sure for their ventilation are going to use an ERV. They're going to bring in some outdoor air, and at the same time, they're going to exhaust outdoor air. And you can set up ERVs now to have a little bit more supply CFM coming in to try to get that positive pressure. And then they'll use the dehumidifier just to dehumidify the house, not using that ventilation. But there is no doubt more and more. I look at plans all the time for passive houses, net zero houses, where they absolutely understand dehumidification is one of the biggest components of that mechanical system to keep the occupants comfortable. Now, in those situations, where we are generating and capturing the heat from that dehumidifier a little bit more, we got to really be thinking through our duct design. Maybe where's the first supply drop that heat could possibly make someone uncomfortable and what we will do, and I always recommend this in tight houses, is, when the dehumidifier is running, to have the fan on the HVAC running at the same time, because what that's going to do is give me really good mixing of that air in the supply ductwork when it's distributed throughout the house. So feeling any heat from that dehumidifier is, pretty much eliminated at that point. You're not going to feel it.
So have there been any innovative dehumidification technologies? Like, is there anything new in the market that we haven't heard?
It's really tough. Everybody wants to use a technology to dehumidify that's not a dehumidifier. People are, well, use an ERV. Well, an ERV is not a dehumidifier. It is an exchange of two air streams, one from the outside, one from the inside. And depending on how much moisture is in each airstream is kind of like how much water you'll prevent from coming in the inside during the summertime. There's no drain. If there's a drain, it's an HRV, and that's because in the winter the core is going to freeze and they need to defrost it. So it will lessen the load. An ERV will lessen the load of the moisture coming in, but it's always going to add to it. Now we're seeing, Tim DeStachio is a HVAC contractor out in Wilmington, and he's doing a data logging right now on using an HVAC system that has reheat. And then also he has a dehumidifier, and he's tracking the energy usage of each one and how it's controlling the moisture. And he's seeing some of the months that right now that the reheat is costing him double the cost of just using a dehumidifier in his climate. So, I have this all the time, and I always joke that, that one of my presentations one of these days is, if you need dehumidification, you just got to use, in the words of Dr. Joe, an effing dehumidifier. I mean, it's because everybody wants to use, and I understand that it's another piece of equipment that I got to pay for. I got to maintain. But the reality of keeping our mechanical systems separate in order for them to focus and being able to deliver what we actually need is the simplest for the HVAC community, right? Contractors. The more complex that we make some of these systems, the harder it is to find people to work on them and being able to maintain them. So keeping things simple. You have your heating, you have your cooling, you have your ventilation, you have your filtration, you have your dehumidification. These are all things that we need in a home, and keeping them simple really is the best way to do it. And because you can, once you start adding a bunch of that stuff, it might not be the systems are complicated, it's the controls that are complicated. And we're already making our thermostats way too complicated for people as it is.
Yeah, I think mine forgot my password, and now I haven't been able to run it from my phone for a year,
Exactly. And then you look at, well, first of all, like you said, okay, ventilation, that's one source of moisture. People's another source. I've been involved in the spray foam industry for a long time, because once you tighten these houses, I think the spray foam industry did a great job saying, well, we're gonna help minimize the amount of infiltration and stop that moisture, which is great. But now you got to bring in that outdoor air, ventilation, and then all the moisture that people generate is going to be trapped inside as well. And so we got to think about that. And everybody lives differently. I say all the time, you can design the perfect envelope, the perfect mechanical system. It can be installed perfectly, which rarely do we do commissioning on our mechanical systems in residential. We're doing more and more blower door tests. So we're kind of, we're commissioning our envelope to figure out what's going on. But, you never know how people are going to live. What I want my thermostat set at is different what my husband wants the thermostat set at. So again, if we're not having the runtime, we're not having the moisture removal. And then, it depends on how many people are living in there. And do we have aquariums? Do we have pets? How many plants do we have? There's so many things that everything works until you put people in it, and then we've got this great house and this great system. And then we put a vented crawl space underneath it, and
that's a no-no.
Blows my mind more and more that, some of these builders are just doing incredible things and great strides forwards in the actual living space of the house. But then we throw it on a vented crawl space, or we put it on a closed crawl space and use supply air from the AC system to quote unquote condition it according to code. And It doesn't work.
Well, the big question then is, if that's the case, not knowing who's going to wind up in there, how do you size the thing?
The dehumidifiers.
Yeah.
What's really important to understand about dehumidifiers and sizing is when you see, like even our units, right? We have a compact 70, which means 70 pints. That 70 pints is at 80 degrees and 60% relative humidity, which is like indoor pool conditions. That's not a crawl space. That's not a basement. That's not typically the living space either. So the DOE in 2019 said, okay, we're going to come up with testing and for whole house dehumidifiers and testing for portable standalone dehumidifiers for the applications they're typically used in. So the DOE said a typical living space condition is 73 degrees and 60% relative humidity. And a crawl space basement application is typically cooler, 65 degrees and 60% relative humidity. So when you put a 70 pint like our 70 pint dehumidifiers, we have a whole house 70 and a portable standalone 70. The whole house at 73 degrees and 60% relative humidity goes to 55 pints at those conditions because the temperature affects how much capacity that dehumidifier has. Now, that same dehumidifier that's now gone at whole home conditions to 55 pints, at 65, 60 is 40 pints. So when you say you have a 70 pint dehumidifier, it's only 70 pints at 80 degrees and 60% humidity.
Right. But outside of that, how do I, you
need to know.
Should I just buy the biggest?
Well, absolutely not, because it's the same thing happens with a dehumidifier as an AC system, right? We run into short cycling and we don't want to short cycle the dehumidifier. It's not good for the compressor. And what's going to happen is that water's going to sit on the coils and re-evaporate. So what we want to do is we want to look at this space and say, okay, on HVAC side, it's a lot easier because I can get typically what my latent loads are going to be from the manual J. A crawl space, so it's like, well, it could be one end of the measurements. So, what we need to think about is how tight are we getting it? I mean, Sam Myers for RetroTech and I have talked, should we be doing blower doors on crawl spaces? And knowing where, exactly our infiltration is, because infiltration is the number one thing that's going to lead to how much moisture is in that space. But if we do a good job with a vapor barrier, getting a good vapor barrier down there, getting the vents sealed, getting a good solid seal on the door, and trying to minimize as much communication from the outside in the living space as possible, I think our sizing, a 70 pint dehumidifier most of the time is going to work when you've done a good job on let's say a 2,000 square foot crawl space. Because at that point, once you start getting larger in that, it's more about air distribution and air movement in ordering to ensure that the farthest corners of that crawl space are getting the dehumidified air. And that's why we have always, advocated that we're putting some supply duct on that dehumidifier and getting it circulating throughout the crawl space. And also then that dry air isn't affecting the sensor in the front of that dehumidifier. But sizing is an interesting one. I would say that, the compact 70 is if you got to know what kind of encapsulation job you're doing and closing that crawl space. And if you're doing a really good job of that, at that point, 70 pints in a, 2,000 square foot, maybe even up to 2,500, it's when you start getting into compartmentalization of crawl spaces that you're going to have to figure out how you're going to get dry air to those farthest areas. And you might need to use two or use a larger unit. You just don't want to go so large that you're getting a lot of short cycling.
Well, Nikki, I want to thank you so much for taking the time to talk to our contractors today to help give them a better perspective on dehumidifiers, what they can do, how they should go about it, and really just the change in building. So thank you so much for joining us today.
I greatly appreciate it. Always fun talking building science with you.
Well, thank you. And for all you folks out there, I'm telling you, if you have any questions on dehumidifiers, reach out to us, reach out to the folks at Santa Fe, reach out to Nikki. We are all here to help you with any questions you have. We want it to be one of the most successful products for you. And if you have questions on anything that we carry at IDI, reach out to your local branch or anyone here, where we look forward to earning your business every day.